We will go ahead and get started with our Q&A session now with Dr. Patrick. Hello, Dr. Patrick. Thank you for joining us this morning.
Hi, it's great to be here.
Yeah, so we do have a question coming in. So the first one is going to be, what kind of seagrasses are there?
Well, here in the Chesapeake Bay, we actually only have one true seagrass. And so that's what people refer to as eelgrass, Zostera marina. But it gets a little confusing because we use that term SAV that you saw in the video, submerged aquatic vegetation. And that term actually captures all of the different vascular plants, so true flowering plants that you'll find underwater in the Chesapeake Bay. And there's actually about 26 different species of SAV, but not all of them are seagrass.
Okay. So what's the single biggest threat to the SAV or the eelgrass in this region? What caused its destruction? What current threats do we still have for it?
Great question. Well, historically, the chronic wasting disease was a big impact on eelgrass in the lower bay and particularly the coastal bays, those seaside lagoons. And in the seaside lagoons, it never came back. And that probably is because there just wasn't any seed dispersal. There wasn't any source to come back from. In the lower bay, the eelgrass came back along with a variety of other plants. And the biggest threats in the lower bay, the eelgrass in particular, are going to be eutrophication, so nutrient pollution, sediment pollution, things that are going to lower water clarity. Those are bad for the grasses. And then another potential issue that we're concerned about is climate change. So eelgrass in particular is sensitive to high temperatures. In the Chesapeake Bay, we're at basically the southern limit of eelgrass as a perennial grass that sort of has a 2-year lifespan. So when we get a really hot summer and a really hot day, what can happen is that a lot of the grass beds can die back because they just can't handle those temperatures. And one of the concerns is that if things keep getting warmer, we may get to a point where we can no longer sustain eelgrass in the lower Chesapeake Bay at all. We're not there right now, but that's a concern for the future.
Gotcha. Yeah, someone actually asked pollution, as you were saying, nutrient pollution. So that's definitely a factor. Mm-hmm. So we have a lot of questions coming in now. So I think it briefly touched on why the seagrass disappeared originally. Mm-hmm. So, okay. Could you go into that a little bit? We have a question about it.
Oh, sure.
So why did it go away?
So there was a pathogen, it's a seagrass wasting disease, which affected literally all of the eelgrass in the Atlantic back in the 1930s. And it was a pretty spectacular event. We basically saw the disappearance of eelgrass everywhere in the Atlantic on both the east coast of the United States and also the west coast of Europe. I mean, it just disappeared. And eelgrass has a distribution from both, we have populations in both the Atlantic and also in the Northern Pacific. And the Atlantic populations were seeded from the Pacific population. So there's less genetic diversity there to begin with. And it just responded very poorly to the disease. Fortunately, there were these little pocket populations in lower salinity areas up in the tidal creeks. And this is kind of like the predominant theory about where the recolonization came from. They weren't hit as hard by the disease, and so they were able to reseed the embayments and come back. And so what we saw is that in the time after this big disease outbreak, there was regrowth in the 40s and 50s, and we saw the return of all these populations. And the coastal lagoons on Chesapeake Bay, they just didn't have those refuges, and they're kind of isolated and cut off, and there was no seed dispersal. And so that's why it never came back there. And also that's why we think the restoration was so wildly successful as compared to other restorations. Because usually when you lose seagrass from an area, it's because there's some kind of problem. The environment can no longer sustain the seagrass populations. And so just like if you were, like if you're trying to grow something in your garden, if the soil conditions aren't right, or if you've ever lived up in, I don't know, Wisconsin or Michigan and tried to grow tomatoes in March and they just don't do well, if the conditions aren't right, it doesn't matter how much seed you're going to throw out there, they're not going to do well.
Yeah.
And here in the coastal lagoons, it turned out that that was not the problem. The conditions were fine. It's just that there were no seeds. And so as soon as they started seeding, they took off. And it is the most successful large-scale restoration of its kind in the world.
That's amazing. So we do have quite a few questions coming in, but the most popular one seems to be, why is it called eelgrass?
Oh, yeah, that's a good question. You know what? I don't know. I'm gonna say I don't know the exact answer. I mean, it looks a bit like a little sand eel, and that's what I always thought. And when growing up, I used to spend my summers up in Massachusetts, and we'd find little sand eels in the eelgrass, and so that's why I always thought it was called eelgrass. But I'm not sure actually. Good question. I'll look that up.
All right. So another one is, what is the maximum depth that SAV can survive at in the bay?
Great question. So each SAV species has a different light need. And what dictates how deep they can grow is how much light they're getting at that depth throughout the year. So it's not a physiological depth limit, it's a light limitation. Currently, what we typically will see is we won't see SAV growing deeper than 1.5 meters. But in some areas, it gets shallower. It might be more like 0.5 meters to 1 meter. In other areas, we'll see SAV growing maybe as deep as 3 to 4 meters if it's the right species and the water clarity is good. However, historically, we have evidence that going back to the 1800s, there were SAV beds growing at 20 feet, 25 feet in the Potomac. So water clarity has definitely decreased since historic times, and as such, the depth limit has receded.
Gotcha. Another one is, how is the eelgrass beneficial to marine life? Is it solely a habitat for sea creatures, or does it help erosion of the seabed?
Oh, wow. Yeah, it does so much. It's one of these really critically important foundation species. So it provides habitat. So that's one key thing. It provides forage. There's a number of animals that actually eat the seagrass itself. So it supports waterfowl. There's some herbivorous fish. We don't get so many sea turtles and stuff up here, but there's also larger grazers that'll be eating the grass as well. Additionally, yes, it does anchor the sediment. So it's changing the stability of the sediment. It changes the clarity of the water because when you have dense grass beds, it actually changes how fast water moves through. And as water slows down, particles that are suspended will start to drop down, and then they get entrained in that stable sediment. So that's another good thing that it does, and stabilizes shorelines by that same process. It also, actually, because it's producing oxygen, it can change the water chemistry. It can take up nutrients, and it also sequesters carbon. So if you have a stable seagrass bed, over time, carbon will build up in the sediment under the seagrass bed, and it builds up, and you get these really beautiful large hummocks of sequestered blue carbon. So it does a lot. I mean, it's a foundation species. It changes the whole system.
So on that, it sort of takes up CO2. We have a question. So does it act like other plants and actually absorb the CO2 that's in the water?
Mm-hmm. Yep, it's a true plant, and yes, it does. It takes up CO2.
Awesome. Another popular question seems to be, how are you ensuring that you increase the genetic diversity when dispersing the eelgrass seeds?
Oh, that's a good question. So we are limited to some extent in terms of where we can get our seeds from. But we try to collect from a variety of different places. And another thing is that for the eelgrass in particular, we reseeded those coastal bay populations from eelgrass beds in the lower Chesapeake. But as we continue to do new restorations, we kind of move around from year to year with where we're doing our collecting. And so to some extent, what we're trying to do is get seeds from wherever we can get seeds, so what's feasible. But it's not like we're just have one stock that we're rearing inside of like a greenhouse and it's all clones. We're getting a variety of genotypes from the natural wild populations.
Awesome. So there's another question here. On that note, can other more heat-tolerant grasses be planted in anticipation of further climate change?
That is another really good question. And it's actually one that, so there's some ethical considerations, right? Because the next species that would probably move up here or would move up here naturally would be Haliduli redii, which is a shoalgrass. And so we have natural populations of that in the Carolinas, which is not very far. So basically like a 3-hour drive from here, you can get to natural shoalgrass populations. So one big question is, well, why is it not here now? Or maybe is it starting to show up and we just haven't noticed it yet? And then a separate question is, would it do well here now currently? And then the third question is, if you planted it or if it naturally colonized, what kinds of impacts might it have? Because despite the fact that, yes, that's a seagrass and this is a seagrass, they're not identical. From a morphological standpoint, shoalgrass looks very different from eelgrass. The leaves are a lot thinner and it packs more densely. So there's probably a lot of different subtle differences in the kinds of services it provides for the systems. And we don't know how that would affect other species. So on the one hand, yeah, it could be a good idea, but there could also be unintended consequences. So we've tried to learn our lesson from past really bad situations that have happened with introducing non-native species. And so that's something I'm personally am interested in, but yeah, we don't know whether it's a good idea or not right now.
That makes sense. Someone actually asked if all seagrasses are good or some dangerous.
Dangerous.
So maybe for the creatures or something, could changing those actually harm some creatures, or are they all generally sort of the same, just different physiological things?
Got it. I'd say that in general, we would say that seagrasses are good. You know, the value statement being that like we value all of the things that seagrasses do for these coastal marine ecosystems. But you know, good versus bad, that's something that we are slapping on as a label. There's probably some species that do better in mudflat habitat than seagrass, and probably wouldn't be so happy about seagrass moving into an area. And you know, I know that property owners and boaters sometimes can get frustrated with dense aggregations of SAV around their property. But generally speaking, all of the pros outweigh the cons, and across the world, seagrass is pretty imperiled. So anything that we can do to support existing seagrass populations or help bring them back is something that we should be doing.
Definitely. So I have one more question sort of about the grass, and then we'll go into just a couple quick questions about the project. So one question is, in the video, JJ mentioned that eelgrass is a true flowering plant. Does it have an actual flower?
Yes, it does, but not the way you would think. It does have a true flower, but it's very, very tiny, and they just look like a couple little threads. So yes, it does, but not the kind of flower that you might imagine. I don't have a picture handy, but Google it, and you'll see what I'm talking about.
Very cool. All right, so some people want to know how, in the video, you have to spread the seeds by hand. Do you have a machine that you can do that with now, or do you have to do it all by hand?
I suppose we could probably design a machine to do it, but it's not a very labor-intensive process, and by doing it by hand, we can make sure that we're controlling the rate at which these the seeds are being spread through time. So it hasn't been a problem, and it kind of helps us get a better sort of handle on precisely where we're putting the seeds out. But yeah, I'm sure that you could do a seed spreader also, just in the same way that we've actually, I should say JJ really designed this seed harvester to sort of kind of bring it up to an industrial scale.
Very cool. All right, and so Let's see, do you still have a program that volunteers can grow eelgrass for planting?
Oh, that's a great question. So there are a couple programs that I'm aware of that have uh, ways to get volunteers doing small grow outs or helping with grow outs for a couple different species. Our group doesn't have one currently, but maybe I could send some info to Candace about programs, volunteer programs like that do currently exist that maybe you could put. Is there a way to kind of post that so that folks can get that info, like a place so people can refer to later? Or yeah.
Yeah, definitely. We can upload it once you have the information, because we also have a question of, is there a way to volunteer with the project if you have a scuba certification? So there seems to be a lot of people, and another one asking, what can I do to help the eelgrass? So we have a lot of people that really care and really want to help on this project.
Oh, awesome.
So any information you can give, we can link it probably below the video. It'll be in our documents, and then we'll try to, we'll share them in the resources on the platform.
Perfect. Okay. So real quick, in terms of volunteering, we love volunteers, and actually one of the big volunteer opportunities that happens usually every year is the Nature Conservancy now does a lot of seed collections as well. So we do seed collections through VIMS here in Mobjack Bay, the lower York River, for restoration projects, but then also our partners with the Nature Conservancy out in the Virginia Coastal Lagoons also do seed collections, and they bring in a lot of volunteers to do some group seed collections every summer around this time of year. And that was unfortunately affected this year by the pandemic and social distancing. Weren't able to do that in the same way. But usually that is a big event. And so we can add that to the resources as a great opportunity for volunteering. And, you know, scuba isn't actually necessary for that. A lot of it can be done by snorkeling. It's done at low tide. The scuba is mostly useful for if you're doing transect surveys and you need to do like chute counts. That's difficult to do on a breath hold because there's so many chutes per unit area, and counting them all, you really just need to sit on the bottom and be able to just kind of take your time. And in terms of what you can do as an individual, well, one, spread the word. Tell people about how important, you know, next cocktail party you're at, tell people what you learned here and how important eelgrass is, and seagrass and SAV in general. You know, supporting general policies, that's another thing as an individual you can do. But then in terms of little things you can do, the big thing is water quality. So anything you can do around your property to help with water quality, you should. You know, doing a rain garden, a rain barrel, these kinds of little things that you can do to help improve the quality of the water moving its way into the bay, using less fertilizer on your lawn. These are all things that if we collectively change our behavior, we can have an impact. Another is cars. A lot of people don't realize this, but cars are a large source of nitrogen pollution. About 30% of the nitrogen pollution that makes its way into the bay comes from atmospheric deposition. And a lot of that comes from cars. Some of it's coming from like West Virginia and out further west, kind of moving in with air currents. But some of it is coming directly from our own vehicles. It comes out in our exhaust. So drive less nitrogen pollution. Oh. So that's another thing you can do.
Wow. This has been very informative, but it looks like our time is up now. Dr. Patrick, thank you so much for being here and helping us learn more about this amazing seagrass restoration project and what we as a community can do. Even if it's just drive less, we can help really impact these great underwater flowering plants. And I'm gonna have to take a look at that picture because I'm really interested in that now. For our attendees around the world, please navigate back to the agenda page. So browse all of our resources on the homepage. And I want to thank First Advantage Federal Credit Union for supporting this session. Thank you. Have a great day.
Thank you. Cheers.